infinite series. If we try to add the term of an infinite secant a sub n for n equal 1 to infinity, we get an expression of the form a sub 1 plus a sub 2 plus a sub 3, and we keep on continue adding, which is called a infinite series and is denoted as the sum of n equal 1 to infinity of a sub n, or just the sum of a sub n. Now, how do we talk about the sum of infinitely many terms? There's so many terms to add together. So how do we decide whether the series come to add up to a number or is it not? So for example, here consider the sum 1 plus 2 plus 3 plus 4 plus 5. And you continuously adding it together. What would you get, right? So here we can see that if we start adding each of this term, we can, after the n term, let's take a look at this at n term. The sum is represented as n times n plus 1 divided by 2, which become very, very large as n increase. If you look at the next term, we have 1/2 plus 1/4 plus 1/8, adding up so on and so forth. Note that as n increase, n becomes sufficiently large. The n term is approaching 0 because we divide it by a very large number. Okay, and we'll see how that works. So let's take a look at what does that actually become, and we can do that by using Excel. So let's go ahead and try this. What does this sum actually become as n becomes sufficiently large? So let's go ahead and start with our first term, second term, and let's see if we make it to 30 term. Let's see what happens. And our formula here is 1 divided by 2 to the exponent n. Here we have our n. So let's enter in our formula, equal 1 divided by the power of the number of 2 to the exponent n. So first one we had 1/2, and then we continue on. So let's go ahead and find the sum. What is the sum of the n of the 30 term? Not equal, we add them all together. That get close to 1, right? So it seems like if I go ahead and continue adding it together as n becomes sufficiently large, I'll get closer and closer to 1. So the sum of this infinite series is converted to a real number, that is 1. So then here I can say that, okay, then the sum of a sub n, that is 1 over 2 to the exponent n, is approaches 1. Okay. Definition: given a series, the sum at n equal 1 to infinity of a sub n, let s sub n denote its nth partial sum, then s sub n equal the sum as I equal 1 to infinity of a sub I equal to a sub 1 plus a sub 2, so on and so forth to a sub n. The sequence s sub n is convergent, and the limit s sub n equal s exit as a real number. Then the series a sub n is called convergent, and we can write that a sub 1 plus a sub 2 plus a sub 3 all the way to a sub n, so on and so forth, that equal s. Or we can use the sum notation. The number s is called the sum of the series. Otherwise, the series is called divergent. Definition: a geometric series is a series of the form the sum that n equal 1 to infinity, the a times r to the n minus 1. Note that r is called the geometric ratio. If absolute value of r is less than 1, the series is convergent. If the absolute value of r is greater than or equal to 1, then the series diverges. Let's take a look at the first example. Find the sum of the geometric series. So here we have a sub 1. So note that a sub 1 equal to 5. A sub 2 equal to negative 10 over 3. So that is what? 5 times negative 2 over 3. A sub 3 equal 20 over 9. That equal to 10 over 3 times negative 2 over 3. So here we know r is equal to r is equal to negative 2/3. So the absolute value of r equal absolute value of negative 2/3. That is less than 1. So then the series converge. And since the series converge, I can use the formula for the sum to find the sum of the geometric series. So if a series converge, the sum of the geometric series is equal to a divided by one minus r. So a here equal 5. 1 minus r, that is negative 2/3. So here we get 5 divided by 5/3. That makes 3. So the series converge to 3. Determine whether each of the following geometric series converge or diverge. If it converge, find its sum. So the sum of n equal 1 to infinity, the 2 to the 2n times 3 to the 1 minus n. So first of all, we need to put it into the form of a times r to the n minus 1. So I can rewrite this as, this is the sum at n equal 1 to infinity of 2 to the 2 to the n times 3 to the negative n minus 1. Simplify this. This is the sum at n equal 1 to infinity of 4 to the n times 1 over 3 to the n minus 1. I can simplify this a little more. Rewrite this as 4 to the n, that is, so recall 4 to the n is the same as saying 4 times 4 to the n minus 1. So then this becomes 4 times 4/3 to the exponent n minus 1. So here this is the geometric series with a equal 4, r equal to 4/3. Then this is greater than or equal 1. This means this series diverges. In the next case, we have the sum as n equal 1 to infinity, the e to the 2n. So let's rewrite that into the geometric series. This is n equal 1 to infinity to the e to the second times n. This is the same as saying n equal 1 to infinity e to the second times e to the second to the n minus 1. So here we have a equal to e to the second, and we have r equal to e to the second times n minus 1. So e to the second is greater than or equal 1. So then the series diverge. We can use the sum to write a number with repeating decimal as a ratio of integer. So note that here I have 2 times 2.317, and the 317 is repeating term. Okay, so I can rewrite this as this equal to 2.3 plus 17 divided by 10 to the third plus 17 divided by 10 to the fifth plus 17 divided by 10 to the 7. Okay. Now here then I have a is equal to 17 divided by 10 to the third, and r is equal to 1 over 10 squared. Right? So this meant 2.317, the 17 repeating. This is the 17 repeating. Is equal to 2.3 plus the sum of the geometric sequence come after it. 17, 10 to the third, 1 minus 1 over 10 squared. And this make 1147 over 495. Now we given a series, we want to show that it is convergent and find its sum. So let's go ahead and write out a couple terms to see what are the terms look like. Okay. So first of all, we see that this is not a geometric series. So let's go ahead and write out the term. F sub n is equal to I equal 1 to infinity of 1 over I times I plus 1. So here I have 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus so on and so forth. And this is to the n by definition. that is 1 divided by n times n plus 1. Okay. So let's go ahead and simplify this expression. Now let's take a look at the left hand side. I want to rewrite this using partial fraction. I can have a divided by I plus b divided by I plus 1. This means ai plus a plus bi over I times I plus 1. This is equal 1 divided by I times I plus 1. This means I can have a equal b. This means a equal 1 and b equal to negative 1. So then the left hand side, that is now become the sum at I equal 1 to n of 1 divided by I minus 1 divided by I plus 1. Now let's go ahead and write out the term again. We have 1 minus a half plus a half minus a third plus a third minus a fourth plus so on and so forth to 1 over n minus 1 over n plus 1. Note that all the terms in the middle canceling out. So this sum is equal to 1 minus 1 over n plus 1. Now let's see what happens when n becomes sufficiently large. The limit at n approaches infinity, the f sub n is equal to the limit at n approaches infinity, the 1 minus 1 over n plus 1. This is equal to 1. So the series converges to 1. So the sum at n equal 1 to infinity of 1 divided by n times n plus 1 is equal to 1. In this series here, when we have things canceling out in between, we call this is a telescoping sum, okay, of all the cancellation in between. So that show that the given series is divergent. The sum from n equal 1 to infinity, the 1 to the n. So let's write out the first couple sum. F sub 1 is equal 1. F sub 2 equal to 1 plus 1 half. F sub 3 equal to 1 plus 1 half plus 1 third. F sub 4 go 1 plus 1 half plus 1 third plus 1 fourth. Note that this is greater than 1, right? This is greater than 1 plus 1 half. Let's take a look at this. That will be greater than plus 1 half plus 1 fourth plus 1 fourth for sure. Yeah. And this is equal to 1 plus 2 over 2. If I keep going with this, I can see that f sub 8 will then equal to 1 plus 1 half plus 1 third plus 1 fourth plus 1 fifth plus 1 sixth plus 1 7 plus 1 8. This is greater than 1 plus 1 half plus 1 fourth plus 1 fourth plus 1 8 plus 1 8. Okay. This is equal to 1 plus 1 half plus another half as another half. That equals 1 plus 2 3/2. So if you continue adding this, you can see that in general, this sequence here, s sub n, s sub 2 to the n, so then this is s 2 to the n is greater than 1 plus n over 2. So this meant as s 2 to the n is go to infinity. The sum is go to infinity as n approaches infinity. So then I can say that the series n equal 1 to infinity of 1 over n is divergent. Test for divergence. If limit of at n approaches infinity, the a sub n does not exist, or the limit exists but is not equal to 0, then the series a sub n is divergent. Okay? And we have algebraic property for convergent series. The sum of two convergent series is converging. The difference of two convergent series converge, and since it is the sum, we can always factor out a constant. Show that the series is divergent. The sum of n equal 1 to infinity of n squared divided by 5n squared plus 4. So let's take a look at the limit of a sub n term. The limit at n approaches infinity of n squared divided by 5n squared plus 4, and we use the limit property, and I divide the numerator and denominator by n squared to get 1 over 5 plus 4 divided by n squared. This limit equal to 1/5. So the term a sub n as the limit. For the limit at n approaches infinity of a sub n, we get that is 1/5, and this is not 0. So then the series diverge. In the next case, let's find the sum of this series. So here we're looking at we have two series together. Okay, so I can rewrite this as this is the sum of n equal 1 to infinity of 3 divided by n of m plus 1 plus the sum at n equal 1 to infinity 1 over 2 to the n. So as we do this, I can go ahead and factor out a 3 for the first sum. And for the second sum. That is a geometric series. Yeah. So I can calculate. So we did this earlier. The sum of the first series equal to 1. Right? So this is equal to 3 times 1. I can find the sum of the second series using the geometric formula. So this is 1/2 divided by 1 minus 1/2. So we have 3 plus 1. This equal to 4. So that is the sum.